Good morning, students. Today we are going to discuss about that module number 2, that is network theorems. Here we are going to discuss about that maximum power transfer theorem. So maximum power transfer theorem, first of all, why? The reason behind that, why we are using that maximum power transfer theorem means maximum power transfer theorem is used in so many applications like telephone cables, amplifier systems, headphone systems, radio speaker system applications, amplifier applications, radio application. So in all those applications we are using that maximum power transfer theorem. Let me tell what is the statement of maximum power transfer theorem. Maximum power transfer theorem states that in any two-terminal linear bilateral network which consists of two or more voltage sources or current sources can be replaced by a simple maximum power transfer theorem equivalent circuit which is equal to Thevenin's equivalent circuit, where maximum power is delivered from source to the load, that is the condition when load resistance is equal to the source resistance. The maximum power transfer theorem equivalent circuit which is equal to the Thevenin's equivalent circuit which consists of a Thevenin's voltage source value VTH which is connected in series with a Thevenin's resistance RTH across the terminals AB. Why in case of maximum power transfer theorem we are using the Thevenin's equivalent circuit as an equivalent circuit of maximum power transfer theorem means we have to reduce the complexity when a circuit which consists of two or more voltage sources or current sources. That time it is easy when we approach that Thevenin's equivalent circuit because which is going to simplify that two or more loop circuit into a single loop circuit. So that's why here in maximum power transfer theorem we are taken that Thevenin's equivalent circuit as an equivalent circuit for maximum power transfer theorem. And that too in case of maximum power transfer theorem where the maximum power is delivered from source to the load only at a condition when the load resistance is equal to the source resistance in case of with DC power supply. But in case of an AC power supply, the maximum power is delivered from source to the load whenever the load impedance value is equal to complex conjugate of source impedance. That means for suppose if the load impedance value is 2 plus J3 means the source impedance value is equal to minus J3. So this is the way how we are going to transfer that maximum amount of electrical power from source to the load. What is the reason behind that one to transfer that maximum amount of power? There are some applications where we can increase the sound in amplifier applications, where we can increase the sound in headphone applications, where we can increase that the amount of the current which is flowing in a circuit by controlling that simply called as knob, like radio speaker system applications. So to get that maximum amount of power in those applications, okay, here we are using that maximum power transfer theory. So maximum power transfer theory entirely depends upon when the load resistance is equal to the source resistance, then only it is possible to transfer that maximum amount of the power and from source to the load. And the equivalent circuit of maximum power transfer theorem is equal to equivalent circuit of Thevenin's theorem. Let us check that as I told to you, the maximum power is delivered from source to the load at a condition when the load resistance is equal to source resistance. So there is a need to show that proof that RL value is equal to RS value. As to get the proof that RL value is equal to RS value, here I am going to consider a simple circuit which consists of source voltage as Vt and source resistance as Rt and the load resistor which is connected across the terminals AB, that is RL. It is nothing but a simply called as one loop circuit. The current flowing in this one loop circuit called as I. The current flowing through that one loop circuit called as, if it is I, then what is this I? Mathematically what we can express for I? Mathematically we can express the formula for I. I is equal V by R equivalent value. If I is equal V by R equivalent value, here V means I can write it as Vt, Thevenin's voltage. R equivalent means here RT and RL both are connected in series because only one current which has been flown in this one loop circuit, that is called as I. Therefore in the place of R equivalent we can write it as RT plus RL. If I can write that I is equal Vt divided by RT plus RL, then generally what is the formula for resistor? That is power formula. P is equal I square into RL. Now I am going to substitute in the place of I, that is Vt divided by RT plus RL. Then the above formula can become as like this, that is P is equal, as we told that I square into RL, in the place of I am substituting that Vt divided by RT plus RL whole square into RL. If you simplify this equation here, this equation can become as, that is, here it becomes as Vt square and RT plus RL whole square and again into RL. If it is like this, then the equation is as like this. So that means the maximum power or the power through the load is Vt or Vth divided by Rth plus RL whole square into RL. That is nothing but Vth square into RL divided by Rth plus RL whole square at here. Now what we have to do? The condition for getting that maximum power transfer theorem, that is when load resistance is equal to source resistance, then only there is a case where the maximum power is flowing from source to the load. If maximum power is flowing from source to the load at a condition only when load resistance is equal to source resistance, means I want to differentiate that the power across the load equation. This is the power across the load equation, that is PL equation. For this equation I want to differentiate with respect to the load resistor, because the maximum power is delivered here from source to the load when I am adjusting. When I am going to adjusting this RL value, that is whenever that load resistance knob if I am adjusting, then only the RL value I am going to make it equal to with RTH. Then only there is a chance to flow that maximum amount of the power. That means whenever we adjust, then only the maximum power is flowing. So whenever we are adjusting, then only the maximum power is flowing. That means whenever we are going to make it equal that RL value to RTH, then only the maximum power is flowing. So that's why I am going to differentiate this PL, that is PL is equal to Vth square into RL divided by Rth plus RL whole square, that is equation number 1. I am going to differentiate with respect to RL. If I am going to differentiate this equation with respect to RL, I am going to use that U by V rule at here. Vth square I am taking it as left side. First I am going to apply the differentiation U by V rule, that is V dash d by drl of RL, it becomes as 1, and remaining equation Rth plus RL whole square, that is V dash into U minus V into U dash. So now V into U dash means again I have to apply differentiation plus differentiation for Rth plus RL whole square, that means d by drl of Rth plus RL whole square, it becomes 2 into Rth plus RL and again R. already RL is there here, RL. Then divided by RTH plus RL whole square to the power of 4, and it is equal to 0. Because I am going to start from 0 onwards. Now I am going to send the denominator to that side. If I am sending the denominator value to that side, means that is equal to 0. The numerator value is equal to this one. Now here RTH plus RL whole square into 1 RTH plus RL whole square, then 2 into RL into RTH plus RL is equal to 0. Now here I am going to do that is RTH plus RL into RTH plus RL minus 2RL. That means simply I am going to A plus B whole square formula I am applying here, and I am simplifying this equation. Then the above equation can become as RTH plus RL into RTH plus RL minus 2RL is equal to 0. If I am sending that RTH minus RL, how we got that RTH this RTH plus RL to that side, the remaining equation is RTH minus RL. In this RTH minus RL, if I am sending that minus RL to that side, the remaining equation can become as RTH is equal to RL here. This is the condition where we are transferring that maximum power, that is at the condition when the load resistance is equal to source resistance, or RL is equal to RTH. Thank you.